Good day. Welcome back to Intuos Communications, Intuos Designs. We are going to do a lesson today on how to calibrate a laser, a galvo laser with light burn. It is a really simple task, really simple. So one of the things that you need to do is to have a platform where you can actually mark and see what you're marking, okay? And, galvo lasers, they don't really mark on paper very well because paper burns real quick. So one of the things that, I want to show you guys is basically you take a quarter inch of Lexan or acrylic sheet, and you cover it in black masking tape or black gaffing tape, okay? And that way that when the laser actually burns, it'll actually mark on the tape. You don't really want to use anything else. Metal's too expensive. Give me a minute. We're going to go ahead and set this up. We'll put it on the platform on the galvo laser back there, and get this thing going. So give me a moment. We'll get it all set up, and we'll be right back. All right, so we're back, and we're going to go ahead and set this up. Right now this is let me move my fume extractor out of the way a little bit. This is a 12-inch by 12-inch piece of Lexan. Actually, it's acrylic. It's an acrylic sheet, quarter inch. Try to get some of that off there so I'm not mistaking it. And we'll rotate it. All right. So, inside of light burn, up in the laser tools menu up here in the top, you go here. And you go ahead and you select calibrate galvo lens 9-point correction easy. Okay, you have to know the distance. You have to know the lens working area. So the lens that I currently have in here is a 200 millimeter lens. You can have a 70 millimeter lens. You can have a 100 millimeter lens, 150, 125. They have all sorts of different lenses for galvo lasers, depending on who the manufacturer is. Okay. So you want to go ahead and tell it what size lens you're using. I'm using a 200 millimeter. And then you want to enter the size of the box that is going to output onto the the platform there. So so that that is very important, because you want it to be about 85 to 90% of the entire platform area of the working area for the lens. There's a few reasons for this. The main reason is because when you're calibrating, you want to make sure that the scale is the same as exactly that of your working area. So now that we got it to this point, we're going to go ahead and select next. And in here, it's going to automatically set these settings pretty much for you. You can pretty much leave everything the same. I am going to actually move this up a little bit because I think that 300 millimeters a second is a little bit too slow. I'm going to go ahead with 1,000 millimeters a second, and I'm going to leave it at 20, the frequency at 30. And before we actually start this, I'm going to go back over to the fiber cam, or the fiber laser cam. And what we need to do here is to measure. Before you do all this, you have to make sure you understand the focus of your lens. And that is in a different series, and we'll teach you guys in that particular video how to focus your laser and know that it's focused properly. So I already know that this particular laser and this lens, the focal point is 325 millimeters away from the top surface of whatever you are actually trying to laser. So we're going to go ahead and use my trusty dusty ruler, and come to find out that we are not in the right arena for that particular measurement. It was about 310 millimeters, and right now we're a tiny bit off. So we use the smaller adjustment, and we're right at 325 millimeters to the bottom of the lens. Okay. So now that is actually calibrated in the focus, we will go ahead and calibrate in the actual lens for a 200 millimeter lens. So with that, we go back over, and again, wow. So, again, we're going to go ahead and set this up. We've got it at 1,000 millimeters a second. The power is at 20, and the frequency is at 30 kilohertz. So we'll go ahead and we'll select frame. Okay. And while we're framing everything, while we're framing everything, it's going to show up out and show our framing area of where it's actually going to burn. And we want to kind of center that in there. Try to keep the plate as oriented to the actual working bed. And I'll explain that to you in a little bit. But now that we have that there, we'll go ahead and click on start. Now I'm going to look at this and see how much it actually marked on there. And in my opinion, it's a little bit too light. So I'm going to go ahead and I'm going to up the power to about 30%. And then we're going to hit start again. Look at it again. That one's a little bit better. I'm going to try one more time at 40% to see if it marks a little bit better for me. I got to get the vacuum extractor a little bit more over there. A lot of noxious gas there. I don't want to smell up the entire place. And we'll hit start one more time. And now you can actually see the lines a whole lot better. They look pretty good. Maybe if I would have stuck at 300 millimeters a second, it would have marked a lot better. I don't want to try it. I've already glazed it 3 times. And I don't want to actually put marks into the acrylic below. So once you do that, once you actually mark everything, we're going to come back over to the light burn, and we're going to go ahead and click next down here, and it's going to ask you at what orientation this particular icon was drawn onto the plate. So if we go back over to the into the laser cam and take a look, you can see the icon is actually right. Oops, hang on, let's see if I can get it to show for you guys. I get it in the way. The important part of this is that you can see the icon right about here, and the important part is you have to keep the orientation of the way that this actually burned onto the plate. So the orientation that I see on the plate is actually this way right here, and once you select that, you go ahead and select next, and it's going to ask you, you go back and once you actually select the icon, you select next, and then it's going to ask you to take a bunch of measurements. Now you have to create these measurements, and they have to be very specific, and you need to have a caliper, a digital caliper, in order to do this properly. That way it is done in such a way that it is extremely accurate. Okay, the more accurate you are, the better it is going to be for the actual laser. So if you give me a little bit of time here, I will be right back, and I'm going to measure all these, and we'll put them in, and we'll tell you how to put them in. And obviously it shows you exactly where the measurements are. This would be 1, which correlates to the distance 1, 2 to 2, 3 to 3, and so forth. So we'll be right back, and we'll go ahead and create these measurements, and then we'll stick them in. So we completed these measurements, and we also put them in. You can see all my measurements right down here. As soon as you get that done, so all the measurements are done right over here, and you can see that I placed them in. And once you've completed all of that, you can actually select next. So now it's going to ask for more measurements, except for now instead of horizontal, they're going to be vertical. So 1, 2, and 3 on the top, 4, 5, and 6. Just remember to keep the orientation of that icon the same while you're doing the measurement. Now, one more time, I'll be right back, and we'll go ahead and place those measurements. Alrighty, we have those measurements in now, and you can see that I placed them in. After you get them all done, make sure that you put in all of the decimal points properly. It is very important. We'll go ahead and select next. And what it comes up with is it does all the calculations for your lens correction for you. You don't have to have core files. You don't have to have anything. It automatically does this for you, and it places all the information into the fiber laser that you're currently on. It will put all those into the profile. Okay, so we'll go ahead. There is one thing around here that you need to understand and know about this field size over here. Now, with those measurements, the field size can be larger than 200 millimeters. Okay. That is your deck size of where the actual lens is capable of burning or utilizing the laser in, okay? And you can go ahead and say maximize your work area, and it'll give you whatever it calculated out to be the actual working size. But in my case, the way that I like doing things is not utilizing the extra, just to go ahead and say, look, this is a 200 by 200 millimeter lens. This is the working area that I want, and this is the way that I want it. You select done, and it automatically puts your calculations, the calculations that it did, into your fiber laser, into the settings of the galvo and the lens correction. So this is all that information right here. Otherwise, you would have to have a core file from the manufacturer and load the core file right here. To be direct with you, it is much better to do this one time, or every so often to check your settings that they have on out of everything, and allow these corrections to be calculated out. Go ahead and this is now all correct. So the next thing that we're going to do, to make sure that all of our settings are good to go, is we're going to take that same acrylic board. Okay, now I covered the acrylic board. I covered the acrylic board with both sides. This is the side that I actually utilized for creating the correction. Now we're going to flip it, and we're going to use the other side, and we're going to go ahead and place it onto the fiber laser. Again, aligning everything with the bed. Okay, trying to keep it as aligned as possible. And then what we're going to end up doing, okay, in Lightburn, we're going to create a few boxes. Okay, so you utilize the box tool, and you come over here, and you just draw a box, and then you tell that box that you want it to be 10 millimeters by 10 millimeters. Okay, now you select that box again, and you select the P key on the keyboard, and that will center it to the center of where the fiber laser is firing from. Also the center of your work area. Now what we're going to do is click away, and we'll select that box again. Okay. We can zoom in a little bit and select that box, and then we're going to right click while it's selected. That's weird. Anyway, we are going to go to edit and duplicate. So I created a duplicate of it. So now we're going to go ahead and tell it that we want that box to be 20 by 20 millimeters. Still on the same layer. Okay. Now with that box selected, we'll go ahead and tell it to duplicate again. And then we want that box to be 30 by 30. And then with that box selected, we'll tell it to duplicate again. And then we keep doing this, just incrementing by 10 millimeters all the way out. Now, the reason why you want to do all of them all the way out is because the further out it gets, the more the calibration will skew and not be as correct. So the larger the image or the larger the object that you're actually trying to laze, the more exponential the difference is within the calibration. So we'll go ahead and duplicate this again, and we'll tell it 60. Oops. And then we'll go ahead and keep going. So the shortcut key to duplicate is Control D. Make it a little bit faster. Now, one of the things is that sometimes when you have a 200 by 200 millimeter lens, when you put it on a frame, depending on your laser, your galvo laser, who manufactures it, so in the specs, you might be able to get it to frame at the extent, but that's not always true. So if you get to this point and you cannot see the frame Okay, when you tell it to frame, if you can't see it framing everything or the extents, then you need to reduce the last set of boxes to 195 instead of 200. Okay, 195 by 195. Okay, it just depends on your manufacturer. So anyway, we'll come over here to the layer, and we're going to keep it in line. We're going to go to a speed. Let's try the 5. We'll leave it at 300. So just see what that happens. Max power, we'll say 30%, and then the frequency we will go to 35. Okay. And we're going to leave everything else the same. We're going to say okay, and then we're going to go ahead and hit frame.